Okay, let's get to work on case one, the bigger triangle. And we had a equals 12. I already draw it and wrote it. I'm not going to do it again. So we can see a equals 12, b equals 31, and angle A equals 20.5 degrees. So we're just going to use the law of sines to solve for this side, for this angle, and then we can calculate the other side and come up with this side. Just nothing different than what you've seen. So I'm going to run through it very quickly and probably not even show you all the steps because you're very good at the law of sines. So we have 12 over sine of 20.5 equals 31 over sine B. So let me just draw the big triangle with its parts inaccurately placed. So this is A, B, C. Little a is known to be 12. Little b is known to be 31. So I'm working on that. When I wrote this, I'm working on angle B. So cross multiplying and solving for sine of B, I get sine of B equals 0.90, which is one that works. It's between -1 and 1. Sine inverse of 0.9 will tell me what angle has this as its sine, and it is 64 degrees. So you can check that out. I skipped a lot of steps there. So we come up with B equals 64 degrees. So I'll put it on my little sketch and up here on my big mama. Okay, 64. And now that I have angle A and angle B, I can come up with angle C for the first larger triangle by doing 180 minus 20.5 minus 64. And when I did that, I got 95.5. So that goes here. And that's the big one here, 95.5 degrees. All right, so I put them in both my little and my big sketch. Now, to find sine C, it's regular law of sines. I'm going to do 12 over sine of 20.5 equals C. That's what I'm looking for this time, little c over sine of 95.5. So when I solved that, I got C equals 34. So nothing too surprising about that. So that's 34 from here to here. So I'll put it on the little sketch as well. So here we've solved this, and this is case one. Case one, closed. All right, but SSA is ambiguous. It's the tricky one. So if you remember, we can make a triangle a second way, which would have different outcomes than what I just solved. So I can do the 20.5 degrees for A. I can still keep the 31 here. I can still keep the 12 for side A, but it's going to swing this way, and it's going to come inward here. So now I'm sketching that blue part where this side, it didn't swing out this side, it swung in here, creating different angles altogether than the first triangle that I solved. So I've got to solve that. Let's go back up here. In order to solve this blue triangle, we're going to need to know this angle. And there's a trick in our hat, and that is we can get this because this side is 12 and this side is 12. Do you remember what kind of triangle that makes when you have 12 on one side and 12 on the other, which you will have because we took the length 12 and we just swung it at a different angle. We haven't changed the length of it. The paper is the same length whether it's here or here. All right, so all I know is the side has to meet this side, and therefore it could meet over here or over here. So what's that triangle called when you have two sides that are equal? You used to mark them with a tick mark in geometry, and that was called an isosceles triangle. Do you recall what's true about the base angles of an isosceles triangle? I bet you do. They're the same. So this is 64, then this is 64. But that will get us this one, because this angle and this angle make a straight line. We call them supplementary angles, and we can get this one by taking 180 minus 64. So when I did that, I got 116 degrees for this angle here. So notice that little trick to get this angle. And now we're coming along famously. We can get this in the blue triangle. We can now get this angle because we know this one and this one. So it's going to be 180 minus 116 minus 20.5. And when I did that, I got 43.5 degrees. So this one right here, this blue triangle, the blue angle here up top here with angle C is 43.5 degrees. All right, so down here on my small picture, I can put 43.5 degrees, and I can put 116? What was it? 116, yeah. So all we have, I have side B, I have side A given, so I need a side C for this little blue triangle now. So I just set that up. A over sine A equals C over sine C, so I can get this. So A is 12, sine of 20.5 equals little c over sine. C is across from this angle, the new 43.5. And therefore, we can solve that for C. So when I multiplied both sides by this and solved that, I got C equals 23.6, and you will as well. So up here on the blue, C is 23.6. I'll put it on my little one, 23.6. All right, so here are the answers to the second case. And you can see them inside of this triangle as well. Case 1 is closed. Case 2 closed. All right. So my last thing I want to discuss about this, and that is, how do you know without drawing it to scale, like I had to get out my protractor and make a scaled drawing. Without doing that, is there a way to know if your SSA case has two case answers or one? Because if this number, or if this arrow was long enough, say this arrow went from, let me find something I can cut up. Here's some paper. All right, suppose the side wasn't like this pink side of 12. Suppose it was much, much longer. Suppose it was more like 30 or something, 28. This side right here, it could make a triangle. If I extended this side as far as I need it to, I could make a side way out here. But could I ever swing it in this way and create another triangle? Looks like I could. Let me pan back and see if it'll show it up better. So if this side is very long, this is side B, it can make a triangle this way because I'm going to extend this side until it does make a triangle. But if I keep the point here and I swing this side this way, oh, it made a triangle, a very, very skinny triangle. All right, so I didn't show you a good example. Let me go ahead and shut this video down. I want to show you an example of a side A over here that is known, which will only make one triangle. And it will not be no triangle, it won't be two triangles, it'll be one triangle. And I'll try that again. So hold on to your hats. You'll have to come back for part 3.